This video is for UniGarment, a unified simulation and benchmark for garment manipulation. Garment manipulation faces the following challenges. First, each individual garment is characterized by its unique topological structure with various self-deformation states. Second, manipulation tasks require interactions with different types of objects, ranging from rigid to articulated, as well as fluids and people. Third, that strategies and visual input of garments are highly complex. Manipulating garments faces a greater sim-to real gap. The main contributions of our work can be summaried as: realistic indoor interactive environment for garment manipulation featuring diverse scenes. The first benchmark concentrates on the physical materials and their interactions with garments. Extensive experiments and detailed analyses of state-of-the-art algorithms. UniGarment aims to integrate state-of-the-art physical simulation methods, modern graphics rendering engines, and user-friendly interfaces into a unified framework. This is the architecture of UniGarment. First, UniGarment engine offers data collection pipeline, realistic rendering, support for various sensors and simulation method. UniGarment Assets is a large-scale indoor dataset comprising various kinds of robot end effector, garments, and a variety of interactor including fluid, flow, avatar, and rigid object. Third, we propose 20 tasks to evaluate vision-based algorithm. The bottom show our whole sim-to real design. As different kinds of objects have different physical characteristics, we employ various methods tailored to different objects to ensure physically realistic simulation. For example, we use FEM to simulate hat and PBD to simulate tops. To fully exploit the potential of various simulation methods, we conduct further exploration into different parameter configurations. These parameters encompass, but are not limited to, surface tension, contact offset and reset offset for deformable objects. To fully exploit the model's capacity for understanding physical interactions, we've structured 20 tasks into 5 distinct categories. Firstly, in garment tasks, we focus on basic garment manipulation, including folding and unfolding. For garment fluid tasks, our attention shifts to the interaction between garments and fluids. Following this, in the garment rigid category, we delve into common interactions between clothing and rigid bodies, like hanging clothes. In garment deform tasks, we explore interactions involving deformable materials. Lastly, garment avatar tasks like dressing requires a concept of human intention and safe collaboration. These are demonstrations of some tasks. This video shows the training process of reinforcement learning. Thanks for your listening.